Good morning, children. Today we shall learn about carbon and its compounds, Unit 11 in your science book. Carbon is an inseparable element in human life. Body of any living organism is made up of carbohydrates, proteins, fats, etc., which are nothing but carbon compounds. And we use a lot of carbon compounds in our day-to-day life, like food we eat, medicines we take, clothes we wear, fuels we use, cosmetics, etc. We use a number of carbon compounds. Carbon compounds are found in nature. They are natural, and many man-made compounds are also seen. Many carbon compounds are being discovered yet. No other element in the periodic table forms so many compounds as carbon. And this enormous number of carbon compounds, that is more than 5 million compounds of carbon are known, and it is being discovered even now. And this number is due to the unique nature of carbon. Carbon has certain features which is unique for itself. That is, one is catenation. Last year you would have learnt about it. That is, it forms links with other carbon form linkage bond with other carbon atoms to form a chain like fashion, so that it can bond with carbon and also with other atoms to form many number of compounds. And another feature is tetravalency. Carbon is tetravalent. Its atomic number is 6. Its inner shell has 2 electrons, and the outer valence shell has 4 electrons, 4 valence electrons bond with 4 other atoms or group of atoms to form different types of compounds. So because of this tetravalent nature, it forms many number of compounds. And then multiple bonding is another feature. That is, it not only bonds with carbon and other carbon atoms, but also form bonds with other elements like hydrogen, oxygen, nitrogen, sulfur, etc. And all these bonds, because carbon's valence shell has 4 valence electrons, it forms covalent bonds. So with all the 4 electrons, it forms covalent bonds. And these compounds with this carbon are called organic compounds. Organic compounds have certain features unique for themselves. That is, organic compounds are all having a complex structure. They have high molecular weight. They are mostly insoluble in water, but they are soluble in organic solvents like ether, carbon tetrachloride, toluene, etc. They are highly inflammable in nature, and their organic compounds are less reactive. So the reactions are taking place only at a slower rate. And these organic compounds, mostly they form covalent bonds because it involves carbon and it is tetravalent, and so it forms covalent bonds. Organic compounds have low melting and boiling points, and they are volatile in nature. That is, easily evaporates. So they are volatile in nature. They can be prepared in laboratory, and they exhibit a phenomenon called isomerism. Last year you would have studied. That is, the different compounds have same single molecular formula, but they have different structural formula, and they have different physical and chemical properties. They are entirely different compounds, but they have a same molecular formula. For example, C2H6O is a molecular formula which is exhibited by 2 different compounds. One is C2H5OH, ethyl alcohol. The other is CH3OCH3, that is dimethyl ether. One is an alcohol, the other is an ether. 2 entirely different compounds, but they are different in their physical and chemical properties, in their structure, but they have the same molecular formula. This phenomenon is called isomerism, and they are called isomers. Next, coming to classification of organic compounds. Why should organic compounds be classified? Because we have enormous number of organic compounds. They should be assigned a unique molecular structure, and they should be classified systematically. Only then they can be named based on their structural arrangements. Why it became necessary is that in early days chemists recognized, or they found that the compounds which have similar structural features had identical chemical properties. So they started classifying compounds based on their structural arrangements. So later also chemists classified the organic compounds. Organic chemistry is nothing but chemistry of catenated carbon compounds. The carbon atoms present in organic compounds are linked with each other through covalent bonds and exist as chains. These organic compounds can be classified based on the pattern of their carbon chain. Based on this pattern of carbon chain, they are classified into two types, namely acyclic compounds and cyclic compounds. In acyclic or open chain compounds, the carbon atoms are linked in a linear pattern to form a straight chain. So they are called open chain compounds. These open chain compounds or acyclic compounds are further divided into two types, namely saturated and unsaturated compounds. If the acyclic compounds, in the acyclic compounds, if the carbon atoms are connected or linked with single bond alone, then they are called saturated compounds. That is, they are fully satisfied and they are called saturated compounds. In the open chain compounds, if there exists triple bond or double bond or triple bond in one or two places, then such compounds are called unsaturated compounds. These alkanes, ethane, propane, butane, etc., they are all saturated compounds. Propene, ethene, that is ethylene, propene, they are all unsaturated compounds. Then coming to the cyclic compounds, organic compounds in which the chain of the atoms is closed or cyclic are called cyclic compounds. Cyclic compounds are further divided into two types, namely carbocyclic compounds and heterocyclic compounds. In carbocyclic compounds, the chain carbon atoms are bonded to carbon atoms alone to form a cyclic fashion. That is, if the chain contains only carbon atoms, then you call it as carbocyclic compounds. If the chain contains carbon atoms bonded with other atoms like oxygen, nitrogen, sulfur, etc., then such compounds are called heterocyclic compounds. That is, carbon is bonded to other atoms also, not only carbon, other atoms also. Such compounds are called heterocyclic compounds. In carbocyclic compounds, there are two other subdivisions, namely alicyclic compounds and aromatic compounds. Alicyclic compounds contain one or more carbocyclic rings which may be saturated or unsaturated. These alicyclic compounds contain one or more carbocyclic rings. Then such compounds may be saturated or unsaturated. In aromatic compounds, one or more benzene rings are present. That is, benzene ring is nothing but, imagine a hexagon with carbon at each end, and then in that hexagonal figure, the carbon atoms have alternate double bonds. For carbocyclic compounds, cyclobutane is an example for alicyclic compound, and benzene is an example for aromatic compound. And for heterocyclic compounds, furan and pyridine, they are all examples. Based on the different atoms which bond with carbon, we have different classes of organic compounds. Here we are going to see about hydrocarbons. Name itself implies, that is, compounds that have carbon and hydrogen alone are called hydrocarbons. Hydrocarbons are regarded as the parent organic compounds, and only from these hydrocarbons other organic compounds are derived. The carbon atoms join together to form the framework of the compounds, and to this carbon framework other hydrogen atoms are attached. And how other hydrocarbons are derived from this parent compound is that by replacing one or more hydrogen atoms with other atoms or group of atoms, new hydrocarbons are produced. Then coming to the different classes of hydrocarbons. Before going into the types of hydrocarbons, you should know certain root words with which the hydrocarbons are named. Hydrocarbons are named based on the number of carbon atoms they have. That is, if one carbon atom is present, they are named with the root word meth. If it is 2, eth, 3, prop, 4, bute, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. But we are going to learn about the first 5 hydrocarbons. So based on these root words, the hydrocarbons are given names. And then coming to the different classes of hydrocarbons, you have 3 classes: alkanes, alkenes and alkynes. Alkanes are the hydrocarbons which contain only single bond. Because they have only single bond, they are saturated compounds. Alkanes are saturated compounds. They are also called paraffins. They are represented by a general formula CnH2n plus 2, where n is nothing but the number of carbon atoms. It is just a number 1, 2, 3, which represents the number of carbon atoms. The simplest alkane is methane. That is the first alkane which contains 1 carbon atom is methane. You can derive its molecular formula, that is number of hydrogen atoms it holds, by using the formula CnH2n plus 2. That is the general formula for alkanes. So 1 carbon, so 2 into 1 plus 2, so it becomes C, 2 plus 2, 4, so CH4. So that is the molecular formula for methane, and you can write the structural formula with C in the center with 4 valence electrons bonding with 4 hydrogen atoms. So 4 hydrogens forming 4 covalent bonds with carbon. So because it forms a single bond, so it is a saturated compound. Then next is carbon with compound with 2 carbon atoms, you call it as ethane. Again with the formula you get C2H6. This can be C2H6 is the molecular formula for ethane. This can be written structurally as CH3CH3, or first write the carbon in the center, as that is the framework. So carbon to carbon a bond, and then carbon should satisfy all the 4 valence electrons. So one has been bonded covalently with another carbon, so the remaining 3 valence electrons bonding with 3 other hydrogen atoms. This is the case for both the carbon atoms. So CH3 and CH3. Then next is propane with 3 carbon atoms. So its molecular formula becomes C3H8. You can write it as CH3, CH2, CH3. That is 3 carbon atoms bonded forming the framework, and the end carbon atoms, first and third, having 3 other bonding with 3 other hydrogen atoms, but in the middle the carbon atom has bonded on either side with 1 carbon atom, so it has only 2 more valence electrons left to bond with 2 hydrogen atoms. That is why CH2 in the middle. Similarly for butane, pentane and so on. So we can find the number of hydrogen atoms attached to each compound with knowing the general formula. Similarly in butane, pentane and all, the end carbon will be bonded with 3 hydrogen atoms covalently, and the remaining in the center will be bonded with 2 hydrogen atoms, because on either side they are being bonded with 2 other carbon atoms. Next is alkenes and then alkynes. Alkenes and alkynes together they are called olefins. They are unsaturated hydrocarbons, because alkenes contain one or more double bonds. Alkynes contain one or more triple bonds. So because they contain double and triple bonds, they are unsaturated hydrocarbons. Because they have double and triple bonds, they are unsaturated hydrocarbons. Coming to alkenes, they contain carbon to carbon double bond, and their general formula, they are represented by a general formula CnH2n. That is CnH2n. The simplest alkene itself should contain 2 carbon atoms, because it has double bond and it is bonded from one carbon to another. So the simplest compound itself should have 2 carbon atoms. So first alkene itself has 2 carbon atoms, and from its formula you can find out it is CnH2n. So C2H4 is the first alkene, that you call it as ethylene. The hormone you have learned, that is used for ripening of fruits, that is ethylene gas. That ethylene is this. And then next is alkynes. That here carbon to carbon triple bond is seen either in one or more places, and because they have triple bond, they are also unsaturated, and they are represented by a general formula CnH2n minus 2. So the first, here also the first compound, simplest compound itself should have minimum of 2 carbon atoms, because triple bond is seen between 2 carbon atoms. So the first simplest compound, acetylene you call it, that the formula for it is C2H2. Easy way to remember the formulae, that is alkanes, alkenes, alkynes, AEY. So in alphabetical order. So first CnH2n plus 2, then CnH2n, and then CnH2n minus 2. So difference between alkanes and alkenes is, alkenes have 2 hydrogen lesser than alkanes, and alkynes have 2 hydrogen lesser than alkenes. Naming of these hydrocarbons: alkanes, all alkanes are first given the root word, and they are all suffixed by anes. So methane, ethane, propane, and so on. Alkenes, they are all suffixed by ene to the root words. That is, first alkene is 2 carbons, so ethene, propene, butene, pentene, and so on. Similarly, alkynes, they are suffixed with the root word, that is ine is suffixed with the root word, that is ethine, propine, butine, pentine, and so on. How unsaturation occurs from an alkane, how alkene or alkyne is formed, double and triple bonds are formed, is that, for example, if you take ethane, when oxidation or dehydrogenation occurs, a hydrogen molecule is sent out, that is a hydrogen atom from adjacent carbon are sent out. So what happens, the carbon becomes unstable, because one bond is lost and one electron is free for both the carbon atoms. So these free electrons, they bond together to form a covalent bond. So thus a double bond is formed between 2 adjacent carbon atoms. If it is in the case of alkynes, that is on strong oxidation or so, 2 hydrogen molecules are sent out, or from ethene one more hydrogen molecule is sent out. So another bond is lost for both the carbon atoms. So the adjacent carbon atoms, to become stable, they share the free electron and form another covalent bond, that is a triple bond is formed. Thus alkenes and alkynes become unsaturated. Next is characteristics of hydrocarbons. Lower hydrocarbons like methane, ethane, etc., they are gaseous at room temperature. They are colorless and odorless. They don't have any color or smell. They are insoluble in water. Their boiling point, that is the boiling point of hydrocarbons, increases with the number of carbon atoms, and these hydrocarbons undergo combustion reaction with oxygen to form carbon dioxide and water. Alkanes are least reactive among the hydrocarbons because they are saturated, so they are less reactive. Alkynes, because they have a triple bond, they are most reactive. And then alkanes are saturated, whereas alkenes and alkynes are unsaturated. These are the general characteristics of hydrocarbons. And then how will you know whether a solution is saturated or unsaturated? That is, you have a test for it. You take the sample solution in a test tube, add a few drops of bromine water to it. Bromine water is nearly orangish in color, and when you add the bromine water to the sample, if the color remains as such, there is no change in the color of the bromine water, then the solution is saturated. That is, saturated compounds do not react with bromine, so it does not change the color of the bromine, doesn't decolorize the bromine. But if the bromine solution is decolorized, if the color of the bromine water changes, it is decolorized, becomes colorless, then the compound is unsaturated. So this is a test to find out whether the given solution is saturated or unsaturated. And a small advice is that organic chemistry is highly volatile, so you will forget easily. So as soon as you hear this video lesson, go through the lesson in your book, understand it today itself, so that you will remember. Otherwise, when you open your book a week later or so, you will find it Greek and Latin, you will not understand anything. So kindly go through the lesson immediately and try to understand clearly.